Another part of supply chain management is communicating information in your supply chain. We have to tell our suppliers what to do, right? And you can use phone, fax, email, but you can also do electronic communication. And one method of electronic communication is EDI. And EDI is a transaction format to exchange electronic data. The standard way of sending a message between organizations. And EDI is a extension of an Advanced Shipper Notice, or ASN. And EDI is being converted from private networks now to XML-based standards. EDI is a very old method of sending data. It actually kind of 20, 30 years old. And historically, what you did with EDI was you sent it to a third party, and that third party sent it on to the next firm on a private network. Those have mostly been phased out or replaced with the internet. Some industries still send EDI formatted messages, and I want to go through what one of those messages looks like. So this is from Roadway's website. Let me zoom in a little. And what messages could companies send to each other? Well, Roadway allows you to send an electronic freight bill or an invoice. So they'll send you an invoice in electronic format instead of paper format, saving you the having to retype it into your system, right? They'll send a bill of lading, which basically the shipper sends this transaction set to Roadway, which tells them what's going to be in the shipment. And they'll send you a trailer manifest. They'll send you a shipment status, a 214, EDI 214. And a 214 basically tells you where the shipment is. And this can be sent to either the shipper or the receiver to provide up-to-date information, including the dates and times and the route number and the reference number. So where is your stuff? They'll send a pickup request, where it sends it to Roadway to request a pickup. An acknowledgement, basically a 997, which says that they received it, the message. And so those are the messages they support. Basically, the big ones are the invoice, the bill of lading, and the 214, the status message. And so an example of what one of these messages does, and this is a freight invoice here. And a freight invoice has an invoice date, a pickup date, who the shipper was, who the consignee was, who's going to pay it, the bill of lading, a PRO number, a PO number, which is another number, tracking-based number, a reference number, a couple of reference numbers, and then the freight class right here, 60, the code, the item description, and the freight class, and then the weight, the minimum charge, the rate, and then finally a carrier PRO number, which is the number that you would use to look up the shipment. And so we need all this data about an invoice, right? And this is what it looks like in an EDI message. So that for instance, item 24 is way down here, right there, and that's where you put the freight class. And EDI is a fixed format message structure. So everything has to be in a certain position. And they'll tell you where the positions are. So this is the segment headers, the interchange control, transmission control, functional group header, starting segment. We're not even to the message. Beginning segment of the 214. So the weight of the overall shipment has to be on a particular line in a particular space, and this is what it's telling you. The date has to be in a fixed format. And then you have the individual line numbers on the shipment, which are down here somewhere. Time, routing information, handling instructions, remarks, and so on. Let me explain this real quickly. EDI message. Individual lines have meaning. So the EDI will say on line 2, characters 8 through 15 are wait. You put it anywhere else, it's wrong. Does that make sense? Or it could be that this is payment. So if I say in the characters 1 through 0 to 7 are cost. So if I overextend one position, the message is wrong. So everything has to be in the right format in terms of both lines and position in the message. Okay? So what happens with EDI is your IT department talks to their IT department, you send some test messages, you assume that it's right, and then you start this electronic communication. Now, EDI is the transmission of a document in a predetermined format. You know, individual lines matter. You toss a blank space into an EDI message, the whole message is wrong. It's not web-based or XML-based, and the formats are complex and expensive. Typically, you figure even a simple set of messages will take 60 hours of IT time on both the supplier side and the vendor side. So 60 hours at $100 an hour, 120 total hours. You're talking even at $100 an hour, $12,000 to get an EDI message going. So you got to be doing a lot to do EDI, okay? EDI is slowly being phased out to XML, but it's still widely used. For transportation, you have a bunch of potential messages. The common ones are the tender, bill of lading, shipment status, invoice. Now, the newest message structure instead of EDI is XML. XML is great because it's based on tags, not based on position. So an XML message for making bread would be recipe name equals bread, prep time equals 5 minutes, etc. And then we'll have a title called basic bread, and then we'll have an ingredient amount, and we give what the ingredient amount is, and then we put flour, and then we end that ingredient message. So you can have any length of item in an XML format. So we list all the ingredients, and then we give a step tag, close the step tag, and we say mix all together, knead thoroughly, etc., etc. XML looks almost identical to HTML. Anybody used HTML before? Okay. XML is an extension of HTML for describing data, sending data between systems. XML is widely used. For instance, you can save Excel workbooks as XML documents so that you can change them to a different system. Typically, if you want to export all the data in a database, you can put it in XML and import it somewhere else, okay? XML works great. It's also used a lot to exchange messages between computer systems. So if this computer system needs to talk to this computer system, you can send an XML message. And you can send other messages in XML format. RFID is a huge popular term, radio frequency identification. It's basically used for tracking inventory or anything else. It was a big buzzword from 2004 to 2006. RFID has been rolled out somewhat, but the technology is far from ubiquitous. Today, if I want to get an RFID tag, those cost 15 cents, 10 cents, maybe as little as 3 or 4 cents. And you can put the tag on an item and then read it with a barcode at a distance. And it does have some benefits. Barcodes are still more widely used than RFID. RFID is neat technology because it's a little microchip that has an antenna that powers a transmitter. And that's how it gets the message back and forth between the item. Major trends, outsourcing of logistics functions. Obviously, this is from the book. A lot of companies use third-party logistics providers, which we talked about. Moving towards web-based instead of transaction systems. This is true even in transportation. You can go to their website and look things up instead of getting a 214 status update. And then just building improved information flows along the supply chain. Warehousing is another one of those functions that can be either outsourced or insourced. Warehouses are built based on many different things, and warehousing is often part of the supply chain problem. So, what can we build a warehouse based on? There's a bunch of things, right? Square feet used, pounds in, trucks in, what else?
Location?
Well, location, obviously. Square feet used, pounds in, trucks in, location, hours open. You can also have special charges if a pallet breaks, or repackaging. Pounds, trucks, worker hours. So there are many ways you can bill for a warehouse. And actually, purchasing warehousing services is very difficult because one vendor may charge you so many dollars per 1,000 pounds. Another vendor may be cheaper on dollars per 1,000 pounds, but more expensive if a pallet breaks, or have charges for number of trucks unloaded. So it's very hard to compare. But you don't have to own your warehouses like you don't have to own anything else. Globalization, I can't stress enough the importance of. All of you, and this is mostly for the domestic students, will work in some point in your career on a global team. Most of my jobs outside of Lamar, except for City of Austin, I had to work internationally, which means dealing with people on the phone internationally, coordinating things internationally, and even traveling to foreign countries. So I guess first thing, get your passport. You'll probably use it at some point. The next thing is just make sure that you're comfortable dealing with people, patient on the phone, video conferences, etc. And we are living in a global world. Now, how globalization affects supply chain is that it's very complicated. Because you got to think in terms of total cost or total landed cost. So if we have suppliers all over the world who can sell us this item, how do I pick which one to choose? Well, first you have piece price of the item. And that's usually the biggest chunk. But you also have tariffs and duties to consider. How much is it going to cost to get it across the border? Quality issues, transportation, inventory, warehousing, and probably the most important one is risk. Why is inventory important? Well, if my supplier's down the street, I don't have to hold much inventory for transportation risk, right? If the supplier's 5,000 miles away, I may have to hold several months worth of inventory in case of a container gets lost or a ship breaks down, etc. Right? So usually the amount of inventory you have to hold grows as the transportation delay grows. And what happens if that supplier starts making bad parts? If they're 6,000 miles away, you'll wind up flying those parts, right? And that's a huge cost. Or even worse, what happens if I tell them to make bad parts? I change the design specification, it doesn't work. Well, I have 6 weeks of inventory that's bad before I figure it out. So all of that stuff has to be factored into piece price and, to develop a total cost. So we got to evaluate the suppliers based on piece price, tariffs and duties, quality, inventory, warehousing, and risk. And we got to select based on the total cost or the total landed cost. Moving manufacturing offshore to save direct cost complicates and adds expense to the supply chain due to increased pipeline inventory. The further away the supplier is, the more inventory you have to store in the pipeline. Infrastructure problems, this is a book slide, so they mention political problems. That's not really a big deal. Exchange rates and currencies is an issue. Obtaining skilled labor, not as much of a big concern. With globalization, we have to look at sort of global tooling options. We may build an item in multiple locations. The question is, which parts do we build where? How many different tool sets do I have? Tooling is sort of a medium-term decision that's based on total landed cost. So if I'm building this car, or whatever I'm building in North America, Latin America, Europe, and then Asia Pacific, a couple of places in Asia. We'll put some places, and maybe one down there, one here, one here, one here, and one here. So I'm building this car in 8 places. And for some cars, they are actually built in 8 places. Okay? Some of the GM's midsize car is almost built in 8 places. Question is, how many places do I need to make a particular part? Now, let's say it's a molded part, like a dash or something. Well, I can buy maybe one injection molding equipment. I need 2 of them worldwide. I could put one here and one here, let's say. I might want to buy another one to put here if the volume is enough. Why? Because it's very expensive to transport the stuff internationally, right? You have the price of moving it plus the transportation delays, etc. Now, each one of these tools might be $500,000. So the question is it cheaper to put a tool next to each plant, to put one tool locally, and you'd have to know what? The cost of tool, transportation cost, labor, inventory effect, tariff, ... Okay? So this is a very complex fundamental design problem. How many places am I going to build this part that goes into this item, given that the item is assembled many different places? And these are the sort of problems which you face in a global supply chain. How many places do I want to make my parts? Where do I want to store the inventory? And the critical thing is to have a good understanding of total landed cost. And that's not exactly true. We're having test review next lecture, so no test next lecture. The test for graduate students will be October 3rd. For undergraduates, the test will be the Thursday and Friday, first Thursday, Friday, Saturday in October. You can take it any time, okay? So when is October 3rd? It's not
Next week, Thursday.
Next Thursday. And today is Tuesday. So we'll have a review lecture on the homework and then a review lecture on the other test items. Okay? Any questions, class? Make sure to work the homework before next time. Yes?
When are the papers due?
Day of the test.
The day of the test?
Yeah, I do them before the test because there'll be questions on the papers on the test.
Okay.
So it does you no good to do it the day after the test.
And we submit them online, right?
Yeah, submit everything online.
And
Question?
All 3 papers for the test? Or
All 3 papers for the test. We'll discuss the P&G paper next time. Any other questions?
will you be posting last year papers, a question paper solution or something online for reference? Like it was in OR?
I might. Maybe for the graduate students. For the undergraduates, I'll discuss what the format of the test is going to be next time. So we'll talk about the format of the test. I'm not sure I'm going to post anything. I don't want to confuse. If this year's test is going to be different than last year's, I don't want to post something that's not going to be helpful, okay? Good question. Any other questions? Well, thank you and have a good night. 2 review lectures.